Hello everyone, I'm Amisha. Now we are going to talk about our project, Predict Used Car Prices. Now I'm going to give a brief introduction of our project. Predicting the price of used cars is the significant growth of the second-hand car market in recent years. With the rise of online marketing places and the availability of data on used car sales, predicting the price of used cars has becoming increasingly important for buyers, sellers, and dealers. For buyers, accurate price prediction can help them make informed decisions and avoid overpaying for the used cars. For sellers, accurate price prediction can help them set the right price for their car, increase the chances of a successful sale. For dealers, accurate price prediction can help them make profitable pricing decision and optimize their inventory. And in this project, we are using linear regression technique. This technique mainly used to predict the user car prices based on a data set. The goal of our project is to build an accurate model that can predict the price of a user car given on a certain features such as mileage, model, year, and vehicle type. And next slide, please. Next slide. Okay, in this slide, I'm going to talk about background research. Predicting the price of used car has been the subject of an extensive research in the recent years, with various techniques and models being developed to estimate the value of a used car. One popular approach to predict used car prices is statistical modeling. And also we have different types of techniques such as linear regression, time series analysis, and Bayesian regression to predict the relation between the car characteristics and the price of a used car. Next slide, please. Okay, and our research question and hypothesis is what are the key factors that influences the prices of used cars and how can they be used to predict the price of a used car accurately? And our hypothesis is a linear regression model can be accurately predict used car prices based on a relevant futures and lower the error rate than traditional methods of pricing used cars. And the next method is about methodology, will be continued by one of my group member.
Okay. Hi, this is Sirisha Kurapati. Here I'm going to explain about the dataset. So the dataset we have taken is of size 1.48 MB and it has an information about the used cars within the USA. And the dataset we have taken contains 11,115 rows with 16 columns. Next slide. So here it explains about the data set that has columns and its data types. So we can see each column is defined with the different data types like objects, ins, float, and etc. So each column explains about its individuality. Like one explains about the type of the series, type of the car name, and year, engine horsepower, MSRP, transmission type, vehicle size, and the number of rows, etc. Next slide. So as usual, we know every data set contains little duplicate values, missing values, and null values. Same thing is happening even with our data set. So because of these things, there will be a bad impact on the model and also on the accuracy of the statistical analysis. This can be negotiated by doing some methods like deleting them, imputation, and rest of them. So here we are considering MSRP as a dependent variable and the rest of the variables as independent variables. Next will be continued by other people.
Hi, this is Jahnavi. In data understanding and preparation, we have data consistent data and inconsistent data. To resolve inconsistent data, we use several techniques like data exploration, data cleaning, and data validation. In data exploration, we use summary statistics like mean, median, variance. And in data cleaning, we clean duplicate values, incomplete and missing data, and we resolve formatting issues. And in In the data validation, it's important to validate any data to get accurate and prediction model. For this, we use outliers when we perform some data integrity checks and we convert categorical variables to numerical variables. And next, my friend will continue.
Mute mic.
Sindhuja, unmute.
Hi everyone, this is Sindhuja Reddy, and this is an exploratory data analysis. This is a graph about numerical variables, and the given data set contains several columns related to car features such as year, engine horsepower, engine cylinders, vehicle size, highway MPG, city MPG, and age of the car. Upon examining the data, it appears that the distribution of the year column is left skewed, indicating that there are more newer cars in the dataset. However, there are also outliers on the lower end of the year column, which might be due to some older or vintage cars. As a result, this column might not be useful in the analysis and can be dropped. On the other hand, the engine horsepower, engine cylinders, and vehicle size columns are right skewed, suggesting that most cars in the dataset have lower horsepower, fewer cylinders, and smaller sizes. Meanwhile, the highway and the city MPG columns are almost normally distributed, indicating that the majority of the cars have similar fuel efficiency ratings. However, there are fewer outliers on both the upper and lower sides, which needs to be further investigated. Lastly, the age of the car column is also right skewed, implying that most cars in the dataset are relatively new. However, there might be some older cars that have been included, which can affect the analysis. Overall, understanding the distribution of each column in the data set is crucial for proper analysis and decision making. Next slide. And this is the data about a categorical variable, and the given data provides insights into various characteristics of cars available for sale or purchase, such as transmission type, engine fuel type, brand driven wheels, type of car models, and age. The analysis shows that around 69% of the cars available for sale have automatic transmission, indicating the popularity and convenience of automatic transmission. Furthermore, approximately 60% of cars use regular unleaded engine fuel type, which is a common and cost-effective option for car owners. Regarding brand, around 16% of the cars available for sale are from Chevrolet and Ford, which indicates the popularity of these brands among car buyers. In terms of driven wheels, front wheel drive is the most common option, accounting for around 40% of cars available for sale. The analysis also reveals that sedans have the highest number of models among all types of cars available for purchase, while passenger minivans have the fewest models. Finally, the data indicates that the car available for purchase or sale are typically between 6 and 33 years old, which suggests that buyers can find a wide range of cars in different age categories. Overall, the information can help potential car buyers to make informed decisions when looking for a car that fits their needs and preferences. The next will be continued by my team members.
So, as we can see here that we have created a heat map for our data, and the correlation goes from -1 to 1, which indicates that 1 is correlated to our dependent variable MSRP. And from this, we can see that the engine horsepower is highly correlated with respect to engine cylinder to MSRP. And here we can see that on the x-axis we have taken engine horsepower, and on the y-axis we have taken price, and z-axis cylinder. As the horsepower increases, the price of the car also increases with respect to cylinder. Here in heteroscarcity, we can observe that the distribution is symmetric in regression line, and the data is homoscedasticity here. And we can see that here we have taken multicollinearity. This predicts variable that the linear regression is an independent variable. To test the assumptions, we'll plot residual and fitted values on a plot To ensure the residuals do not form strong pattern, they should be randomly and uniformly scattered on the y-axis. Here in the OLS model, we have performed linear regression. We can see that R-square value for this model is around 0.981, which means that the model is it seems that the model is able to explain. Its variance is 0.91, which is slightly lower than the R-square value due to the inclusion of more predictions on this model. The F-static is 504.3 and the p-value is 0, which indicates that the overall model is significantly statistical. The AIC and BIC values are relatively high, which suggests that the model may be overfitting the data. The model proceeds on the train and test data can be evaluated using the functions and the model reference. The functions calculated and the prints of RMSE are both train and test methods. We can see that the RMSE value is 7397 and the RMSE value is about 6047, which suggests that the model is overfitting and generalized the data. From here, my friend will continue.
Yeah, this is Divya Ravipatti. I'm going to explain about the findings we have found from the predictive model. In this regression analysis, MSRP is a variable that is statically significant. So there is a negative correlation between the engine horsepower and miles per gallon overall. So negative correlation means a relation between the two variables, such as that the value of one variable increases than the other decreases. The hypothesis that certain features and factors can affect the value of car is true. And next, coming to the recommendations. The model for buying used cars is not recommended due to the error, which is approximately 90% of the average used car price. So it is recommended to look deeper into the negative relationship to gain better understanding how age affects the value of a used car. So further analysis, we need to explore a negative relationship between the age and the car and other features. That's it. Thank you for giving me this opportunity.